Good afternoon again. I hope you have enough endurance, specific endurance to listen my speech. My name is Jiří Baláš. I'm from Prague. We have such beautiful sandstone towers, so that's my preferred style of climbing, trap climbing. I am working as a lecturer in outdoor sports department and in the sports research center. I've been responsible for teaching or training coaches by Czech Mountaineering Federation. So that's a little bit my background. I have prepared too many slides, so I will go very quickly through. I would like to cover a little bit the structure of climbing performance and then focus more on fitness, physical fitness part. You know this, that we have several disciplines of sport climbing. There is just one misunderstanding. I didn't understand properly. In England, when you say sport climbing, it's meant that you lead the route. It's lead climbing. But in our understanding, especially in Central Europe, under sport climbing, you have the three disciplines: lead, bouldering, and speed. So when I will speak about this style of climbing, I will speak about lead. So you know that well. The first trials to define limiting factors of performance maybe were earlier than before the conference in Chamonix in 1989, but first published structure was by Colombo and Dupuy from this congress in '89, and the researcher and guides and climbers, they decided that technical and technical factors are most important, physical factor as well, and mental as well. Then we have American approach from Hearst. He says that psychological part, physical part, and technical part has the same importance. So German researcher and lecturer, trainer, different approach, but all these are just theoretical models based on experience. Then there were some mathematical approaches. They were dependent on test selection, on sample size, and different statistical methods. I put it here just to underline that one of the first mathematical model with principal component analysis was done by a professor from Innsbruck, Professor Nagbauer, Fetz, and Butcher in '87. And it was one of the best study done in the climbing research. So there were several trials after, but I will go further. This picture you certainly know. That's the classical structure of sport performance, here transferred to climbing performance by Goddard Neumann. I cannot speak about all limiting factors in climbing. I will focus just on the physical fitness part, which is mostly documented. Ludovic did a nice overview over the coordination and technique part, so thanks for that. So I will focus just on the fitness part, which on the first sight is quite clear, but when we go deeper, it's not so clear. So this structure you can imagine for yourself, or you can you know that. I will go a little bit deeper in the literature. So everyone knows that we need finger strength, but how to assess it? Early study did very simple trials with hand grip strength, and we saw if we had a big sample of participants, there was some relationship, even it's not so specific. I like this picture because it can clearly show that if you are strong enough in finger flexors, so you are right.
It's the one.
Okay, yeah. So if you are strong enough, it doesn't mean that you climb well. So even novice climber who is working manually has a big hand grip strength, can climb only 5th or 6th level on the UIA scale. But to be good in climbing, you have to be strong. But how much is the question? So, for example, these are too strong for their level, so probably they don't have proper technique, proper endurance. On the other side, if you are not, if you are somewhere here, some strength training would be beneficial for you, and your, for example, main your best part is probably technical, some factor. So with this testing, we will not find a big relation or a close relationship to the climbing ability. However, if we can manage to assess finger strength more specifically to climbing on a rank, we can obtain closer relationship to climbing ability. But as you see, these correlations or these coefficients of determination range or differ from one study to the other. Why? It depends on the sample size, but also on the methods of measurement. Sometimes force or grip strength, finger strength is measured in position under the heart level, so it's more concentric and then isometric. Sometimes it's measured over the head, so the beginning is eccentric and then isometric. Sometimes there is a fixation, sometimes not. Sometimes you have shoulder elevated, sometimes you have a shoulder in good position. The rank size, it can affect the relationship to the climbing ability, the shape of the hole, the grip position, 3 fingers, 4 fingers. So all this can affect the specificity of your testing, and the research community is not yet unified. What's the method how to assess maximal finger strength? It was already said that not only maximal strength, but also time parameter to develop maximal strength is quite important for climbers. Firstly, it was shown by Fancini et al. He showed that climbers can develop maximal strength faster than the novice climber, and boulderers are better than elite climbers. This was developed further by a French team around Levernier and Lafay, and they focused which parameter of rate of force development is more important, if it's the early part of the contraction or the second part of the contraction. And it was shown that especially this part of contraction are more important. So how much force you are able to develop in 200 milliseconds, this parameter can distinguish more advanced from less advanced climbers. Not the first part of the curve. So that was finger strength. Now a more complex finger endurance. We have several possibilities how to assess finger endurance. Mostly dead hangs are used. Then many studies used sustained or intermittent contraction from 40 to 80% of maximal voluntary contraction. All-out tests are quite popular recently, or some researchers or even trainers are using climbing technically easy routes on the treadmill or on some inclinable wall. Dead hangs. What are the problems with dead hangs? They are good if you want a first check how strong he has the fingers. I said strong. Why? Because dead hang is very closely associated with maximal strength. Actually, who is stronger, he uses less percentage of maximal voluntary contraction to endure the hanging. So if we put together finger strength and finger hang, we can find such a relationship, a very close relationship, especially in the first part of performance. So if you hang up to 80 seconds, so the performance is very affected by maximal strength. So dead hangs do not measure, do not assess endurance, but more maximal strength. Only very strong climbers can use dead hangs as endurance measure. Then we have sustained and intermittent contraction tests. What's happening in the muscle during this contraction? There is an increase of intramuscular pressure and partial venous occlusion. It means that the blood cannot go out of the muscle, and the muscle has to be more, the metabolic pathways are more glycolytics. During intermittent contraction, there is a partial relief of the occlusion, so the blood can go out of the muscle and oxygenated blood can go inside the muscle. There was a recent study from Polish and Bulgarian guys now published, and they show what's the energy system contribution during sustained and intermittent contraction at 60% of maximal MVC. During sustained contraction, which is this part, you have the first column, the white one, so around 30% of the contraction is done by aerobic system. Actually, it is the oxygen which is bound to myoglobin especially, and then the rest of the test you have to rely on alactic and lactic system. I would just focus on the third column, the lactic system. It's only responsible for 15% of the whole ATP resynthesis. During intermittent testing, when you have 2 seconds of relief during the contraction, you will receive or you will get the aerobic system contribution twice as high, so 60%. So just the intermittent testing, the short time of contraction will increase the aerobic contribution. And if we know that, if we do both tests together, we can estimate how much the climber rely on which system, if it's more glycolytic, lactic, or aerobic system. So if we use intermittent and sustained contraction, it's good to do them together. I can skip, no, not yet. So during continuous testing, it was shown that climbers have similar time as non-climbers. The time is similar, but the absolute force is greater in climbers. However, if we do the intermittent contraction, climbers perform significantly longer. So why it is? So something had to happen during these short relief phases, and that's indicated on the picture. During contraction, that's the red line, you deoxygenate muscle. So Tomáš already explained with the NIRS signal, we are able to follow what's happening in the muscle. And in this picture, you can see that climbers can deoxygenate from the beginning of the contraction much more than non-climbers. So they are using more oxygen from capillaries, they are able to extract it, and non-climbers are nearly not able to do that. And during recovery, again, climbers are able to recover quite fast. And from this point of view, it clearly showed that more advanced climbers are able to use the better oxidative system locally in the muscle. Another approach or confirmation of this hypothesis is a study from Simon Fryer from 2015. Again, there are oxygenation index in forearm muscle, flexor carpi radialis and flexor digitorum profundus, and non-climbers are not able to desaturate the muscle. However, elite climbers can desaturate to really low percentages. The test, which was already presented by Tomáš, how fast you can reoxygenate the muscle. So this is the standardized test after calf occlusion. Better climbers are able to recover oxygen much faster than non-climbers. Another way of testing is all-out test. These tests were presented by David Giles from Derby and now in Lattice. The nice thing on this test is that it's very practical for training, because it can determine critical force, which is force where maximum metabolic state appears. And for training, it means if I have a hangboard with force sensors, many were presented here, so I can test myself for my critical force. And if I have this hangboard, I can train sustained intermittent contraction around this critical force, and I will have a clear picture of how I am training. So if I am over the critical force, it will be more to glycolytic system. If I am under the critical force, it's the highest intensity way where I am developing oxidative capacity of the muscle. So to conclude this endurance stuff, so dead hangs, they are very good predictors of climbing ability. However, the intensity is dictated not only by body mass, but especially by maximal voluntary contraction. Sustained and intermittent contraction, sustained contraction is not so ecological valid because it doesn't correspond to intermittent nature of climbing. However, it's good to assess the anaerobic component. Intermittent testing is ecologically valid. However, we need more information from other tests, like from sustained contraction or some NIRS, to really well interpret the results. And all-out tests, they are new. They are very. I like them very much. Because they are very practical and they enable to determine maximum metabolic state. Oh, these were hangboard tests. Now treadwall test or climbing test. I will skip the first study of Vanessa Romero, the second one, and Wood. These were two first study on treadwall. The next one was done by Simon Thayer, and they used incremental test on treadmill, a climbing ergometer with increasing speed. And they found out that maximal oxygen consumption is a good predictor of climbing ability, and the same for maximal desaturation during the climb, and the oxidative capacity index, the standardized test. So together they were able to explain quite high variability in climbing performance. Then we did we had another approach. We didn't increase speed because it's not climbing specific. We increased angle, and we found out that nearly everybody obtained or achieved the same VO2 peak, but advanced climbers achieved it in more steeper angles. And here we haven't confirmed that oxygen desaturation is a good factor to follow. However, submaximal VO2 or submaximal muscle saturation were very good predictors of climbing ability because of the probably better economy. A big table, a lot of numbers, so excuse me for this. How much do I have?
10 more minutes.
Okay. So we compare tests of on a treadmill with tests on hangboards, and we related the results to climbing ability. So that's the first row. So the steepest angle the climbers could climb was in highest correlation with climbing ability. That's quite clear. This is some tread wall muscle oxygenatic breakpoint. I will skip this. Then the results from hangboard test, from sustained contraction, quite strong relationship, from the intermittent test, and from maximal finger strength. So you see that the maximal finger strength is not the main determinant of climbing performance, especially in this study. Endurance tests were much more related than strength component. And even if we reduce the strength component from the analysis and we do the partial correlation, so these are the relationship reduced from the effect of strength, we can still see a strong relationship to the climbing ability. So all tests, all endurance tests are not bad to assess climbing ability, but every test assess something different, and we have to keep in mind this. Just overview for isolated or whole body test. If we test forearm muscle in isolated way, we have quantified intensity control, we have force, impulse. There is very small learning effect, which is not the case of tread wall. And there is a very little effect of systemic function, like metabolic reflex. So during whole body climbing endurance test, we have these systemic factors which influence final results. There is the effect of technique. If the route is not simple, there will be a learning effect, so you will need more time to learning. So finger flexors are behind us. I will go faster for upper body. 5 minutes, okay, it will be very fast. So just to show upper body strength power, quite high relationship to the climbing ability, similar to maximal finger strength. We can test diagonal reach or paddle slap, one arm, both arms. In dynamic way or endurance, still there is a stronger relationship, especially for bent arm hang. Flexibility, there were several trials in the literature, generally very low relationship to climbing ability. It appears that you need just certain level of specific flexibility, and that's enough. Most related to climbing ability is this one. Sorry, this one, but from some level, it's not about flexibility, it's more about finger strength. So that's why it's related so much. Core strength, lower extremity strength. I thanks Fabian to present some general tests which appeared in testing climbers. It was already shown that lower body strength, counter movement jump, squat are related to speed climbing. We don't have specific core strength or endurance test, but again, it was shown that high elite athletes has or score better than lower grade athletes. So I'm going to conclusions. So despite of number of studies in climbing, in the fitness assessment, there is low agreement on assessment tools. Finger strength is maybe overestimated, not only in the research, but also in training. We have experience from our lab, from tests with national teams, that they are very strong for their level. Another aspect of strength are important, like rate of force development. Upper body seems as much important as fingers. Climbing specific endurance is very difficult to assess. There are many approaches and we have to select appropriate methods. And we are still missing proper tests for core or lower extremities strength and have normative data. So thanks for listening. And at the end, last invitation for a similar climbing seminar, which we organize in Charles University Faculty of Physical Education. If you are interested, just open these pages and you are greatly welcome there. So thanks.
Thanks a lot, Jiří. Sorry for rushing you to the last slides. But now we have time for one or two questions. There was one raising hand. Yeah.
I have a question. Maybe your opinion differs to mine. I don't know, but there was some data that showed that you showed it as well. That good climbers have high aerobic VO2 max when climbing. So I saw that a flood on Twitter saying, "Get your running shoes on, start training." Do you agree that that is true or not? That we should run for climbing. Again, maybe you disagree with me, but I have my own opinion.
It's a little bit like with flexibility. We need some basic level of running VO2 max. We have to consider that during exhaustive climbing, the VO2 uptake is around 40-45 milliliter per kilogram. And if you don't have general fitness, so you are at 40, so it means that you have to slow down the pace of climbing. And if you slow down the pace because of the speed, because the speed is the main determinant of VO2 in climbing. So if you slow down, you have a longer static contraction on the holds. And if there are longer static contraction on the holds, you desaturate more the muscle and you are more dependent on glycolytic system, which leads to early fatigue. So you don't need a high VO2 max, but you need a certain systemic level to deal with climbing speed.
Stop running to work.
No, absolutely. I 100% think running is useless. Climbing, yeah.
Okay. Any other question? Okay, then I think we should go on. Elisa, that's one.
Just a quick one.
Okay.
Just if you observe big differences between left and right kind of asymmetry when you do this kind of testing, or if you have a good symmetry between left and right for all the testing about force, either for fingers or for arm.
Yeah, there are many asymmetries in climbers, and it's quite interesting that, for example, for finger strength, dominant is stronger often, but it's opposite with shoulder. If someone is stronger with right hand, then he has stronger left shoulder.
Okay.
But it's just the observation. I don't have now the data. But it's good to observe the asymmetry. I agree, and it's a good output for trainers and climbers. And I think Fabian also may mention it, that asymmetries are important, and not only around the maximal strength, but unilaterally, like in soccer, hamstring and biceps. So in climbing, it could be external, internal rotation. So that's another topic.
Can I extend my question to not rock climbing, but do you think that this type of testing can be replicated for ice climbing? Because the way we do ice climbing is with using ice axes, and the fact that we are holding ice axe might change the way we grasp. So instead of that and using fingers, but using axes,
certainly.
would you use the same or reuse some of this testing, or not specially?
For fingers, certainly I would change the grip, because there are different muscles involved. So testing ice climbers on their own doesn't make sense much for me.
Okay. Thanks.